Hello ladies, it's Mr. Ursel, and today we're going to be looking at the Pythagorean Theorem again. So today's learning target is the exact same as Thursdays. I can apply the Pythagorean Theorem to determine the value of a missing segment length on a right triangle. So again, I have the theorem listed. Pythagorean Theorem, if a triangle is a right triangle, then the square of the length of the longest side is equal to the sum of the squares of the lengths of the other two sides of the legs. And our theorem rule is a squared plus b squared equals c squared, where A and B are the legs of the right triangle and C is the hypotenuse, which is the longest side across from your right angle. So what I'm going to do is I'm going to draw on a right triangle to basically say this is what our triangle would look like. And if we look at that visual on the left, we have a right triangle drawn. It's not 100% perfect, but we have our A, our B, and our C labeled, and our a squared plus b squared equals c squared. So let's go down to our model problems, and I believe it was Lysandra. I'm not 100% sure if I remember, but I believe it was Lysandra who asked, does it really matter where you put your hypotenuse? And yes, it does matter. It always has to be across from that right angle. So C will always be here. So Pythagorean Theorem problem level 1. Find the exact length of the missing side on the right triangle. Well, if we look, we actually want to find our hypotenuse. So we're going to go over. We're going to put a C or an X. It doesn't matter. And the first thing we do always is we write down a squared plus b squared equals c squared. So I'm going to do a squared plus b squared equals c squared. We now go to our image and we label our a and our b. So I'm going to make 3 my a, 5 my b. It doesn't really matter which one you make it as long as you don't make them a c. So we now go back to our rule and we substitute. Into our equation we substitute. So I have 3 squared plus 5 squared equals c squared. Well, now you have to ask yourself, what's 3 squared equal to? 3 squared is equal to 9, because 3 times 3 is 9. What's 5 squared equal to? Well, 5 times 5 is 25. And then I set that equal to c squared. I now add my 9 and my 25, and I get 9 plus 25, which is 34. So I get 34 is equal to c squared. And now what I'm going to do is take the square root of both sides to get rid of my square. So I get c is equal to radical 34. And that's your final answer. Now let's go on to our next example. Find the length of the missing side in the right triangle below in simplest radical form. So the first thing I do is I label my sides A, B, and C. Remember, the side across my right angle is always C. So I have my A and my B. Now, what I'm going to do is I'm going to substitute them into my formula. So a squared plus b squared equals c squared. Now I substitute them, so 1 squared plus b squared equals c squared. I have to ask myself what 1 squared is. 1 squared is 1. B squared is just b squared. 12 squared is 144. I have to ask myself, how do I get this 1 from here to the right-hand side of my equal? So the best way to do that is to subtract 1 from both sides. Subtract 1. So I get b squared is equal to 143. I take the square root, and I get b is equal to radical 143. And that's your final answer. So that's saying my missing side length is radical 143. Now, a certain television is advertised as a 45-inch TV, the diagonal length. If the width of the TV is 36 inches, how many inches tall is the TV? So the first thing I'm going to do is I'm going to just draw like a rectangle because TVs are typically rectangular. And that's my diagonal length. So that's the length that goes across my screen. So I'm going to just draw my diagonal of 45. It's not perfect. And if I look, I have a right angle here. So 45 is my hypotenuse or my C value. The width of the TV is 36 inches. So again, I want to find my B value or my A value, however you want to call it. So I do my Pythagorean theorem. which is a squared plus b squared equals c squared. So I have 36 squared, because that's my a, and this is my c. So I have 36 squared plus b squared equals 45 squared. I have to ask myself what 36 times 36 is, or 36 squared is. 36 squared is 1296, so I have 1296 plus b squared equals 45 squared, which is 2025. I now have to ask myself, how do I get this 1296 over here so I can keep my b squared by itself, and I subtract 1296 from both sides. My 1296's cancel. So I get 2025 minus 1296, which is 729. So I get b squared equals 729. And again, the only way to get rid of that square is to take the square root of both sides. So I get b is equal to 27. And that's your final answer. Now let's go on to our final example, where we find the area of the triangle below. We know our area formula is base times height divided by 2. I know area is equal to base times height divided by 2, so I'm going to do my parentheses and put them all over 2. I know my base is 7 plus 3, so 10. But if I look at my image, I don't know what my height is, so I have to find out what my height is. So I look a little deeper, and I actually have a right triangle right here. And I have to use Pythagorean Theorem to find that missing side length. So I have my a, my b, and my c. So we know a squared plus b squared equals c squared. We said a was 3, so I'm going to do 3 squared plus b squared equals c squared, so 5 squared. 3 squared is 9, so 9 plus b squared equals 25. Subtract 9 from both sides. B squared equals 16, and then last but not least, I take the square root. So b is equal to 4. So I'm going to erase my b now and substitute a 4 for my height. So I ask myself, what's 10 times 4? It's 40. What's 40 divided by 2? 20. So my area is 20, and that's your final answer. If you have any questions, please email myself or Miss Daniel. And don't forget, office hours or extra help is offered with Miss Daniel every Monday, Wednesday, and Friday during second period. Have a great day, ladies.